are working on, I'm adding a note here as I talk to you. We are working on our Python certification, walking through all the things that we need to know, basically, or that are part of that test or part of the syllabus. And this episode, we're going to continue talking about classes. Last time around, we went through some very basic examples. We're going to get a little more involved in it this time. Focus mostly on inheritance and some things that come out of that. They do apply to classes in general, but it makes more sense in the inheritance context. So just as a note, sometimes we've changed, we've sort of have something file name based on topic, and we have classes, but this time we're going to actually be in inherit. We're going to focus really on the inheritance side of that. So let's dive in. We don't need this guy right now. So we're going to go back to sort of what we had. We're going to start with our simple class, which if you remember, we had a couple properties, and we had basically the constructor, and then we just had this display that it had. And so I'm going to add another one that's going to be a little bit more, just because we're going to have a couple of functions to work with. So let's just create a dump, and this one's going to be, let's just do return, whoops, if I can do this right, return self.myname plus, we'll do this, plus string value. So we've got a couple of methods in a very simple class. And the first thing we're going to do is we're going to work with inheritance. And just to show here, let me just sort of dump this, do this. So print simple dot dump. And if we use these, 3 inherit, there we go. Constructor call destruct. Oh, value is not defined. I'm sorry, because that has to be self.value. My mistake. Okay, so now we can see here's our dump, and it's just a default constructor, so there's not a whole lot of interesting stuff in there. Now let's say that we want to create less simple, and this is going to inherit from simple. So we're going to add on top of the simple class. And what we're going to do here is we're going to add a new property, which is going to be, let's see if we have a name, a value, and a, let's just call it an address. And then we're going to add, let's see, we're going to do the same display. Well, actually, let's do the same dump. It's going to have a dump, except for now, it's going to do super, and it's going to do, let's see, well, let's do this. And then return self.address. We're going to default this to not entered. Let's not, we'll leave it here for now. Let's just do it like this. So, let's just do self.address. Okay, let's just leave that because I think that'll all compile. Yep, okay. So starting with the simple stuff here, no pun intended. So we're inheriting from simple. So what we're going to find out here when we create we'll call him L simple, and it is less simple. So when we inherit from L simple, we can actually do the same things because, whoops, we inherited from it. So we already get the display in the dump. And we'll see that here. Is that, so here when we called dump, and I do super, now what super does is actually going to get it returns a object. And so what we really want to do is let's see how we do this one. And then he does the, or prints the address. So you can see that even though here, and let's play with this a little bit more before I mess with this too much. So here we can call display, but display doesn't exist in Less Simple. We're actually calling display up here, which is just my name. And notice that my name's not here. Now, if we wanted to do, well, let's just take this. So we can, there's two things we can do. We can either overwrite dump and just do this. So we can just say, oh, let's do that, plus, let's do that. And so we can do it here, and we can see that it's going to write. It gives us what we need, but we may need to call something further up, and this one actually just overwrites that one. So we can either notice that it's doing the address, it's not doing this other piece. If we don't have it at all, then it's still going to run. It's just going to call the one up here. It's going to call the parent method. So one of the things we can do is, let's do display, because that's a little easier to deal with. So display prints a name. Now what we can do is we can add to it. So we can say, if we call super, this means it's going to call the parent display. And then let's just say I'm going to do print self.address. So now if we do the display, let's just do that at the end. So now what it's going to do is it's going to go up, because we called super, and that's the first thing we call when we do this, is that we say, all right, go up and deal with this, do what this tells me to do, and then I'm going to do some other stuff. And if we do that, we see that it calls, so it should be my name, which is default. Oops. Let's see, what did I call? So L-simple display calls this display, which calls super, which should print my name, not entered, and then address. Oh, and then prints addressed. So let's just call, let's do this. Base, it's going to be hard to follow maybe. And so he's going to do base display, and then let's do child display. Let's do, and we called L-simple.display. So it's just calling the child display. So it's not actually calling this. I'm sorry. This actually has to be super dot, because that's just, super gives me the class. It doesn't actually call. I forgot, this is different from like Java and C#. A lot of cases it'll just call up this, but I here have to actually, so super gives me a class instance. And so, whoops. And so now I can, if I can get around to what I had, now we can see that it calls the super. So I can actually call up and add on top of stuff as needed. Let's see. So now another thing that we want to do, oh, well, let me look at this. So now also what I can do is I can do L-simple, and I can, even though it doesn't necessarily have that, I can still set my name equal to ls name, and I'm going to do L-simple dot value equals ls value. And so now I can see, oh, where did that go? So I go here, I can see that here's my ls name and value. I can see that where I called it after I do that little dump. So I can set those values. I can also set the address. Equals. And I can get that. And so I can actually, so now let's actually extend dump. And so I can do, so I'm just going to do, whoop, it's going to be dump. Whoop, or dimp. So I can take that. And I'm going to do plus at soft.address. So now I can make a more complicated dump here. Here we go. Here's my simple dump. So now I can actually extend off of that. Now, I may not want to allow child values to change. So I could have like a ID equals, we'll start with 0. And then in the initializer, we're just going to do self dot ID equals random 10. We'll just do that. Probably doesn't like that because I need to import my random.random. Okay, we'll do that. And now I can here, let's say in this dump, I'm going to do a bracketed just to show that. Now here I can do self dot ID, and I want to be a string. Whoop. So now if I do this, I'm going to see my IDs pop up. Whoop. Oh, sorry. Let's do 100 times that. And this, let's make that int. Let's just leave it like that. Forget it. I'm not going to worry about that. And not plus. I want times. So now we'll see, here's my ID. Yeah, let's go ahead and make that an int. There, so here's my ID. And so you can see every time I'm getting a different one. So here's, I generated an ID. And notice, even though I don't have that init anywhere, it's picking that up here in my less simple. So it creates, there was for my simple, here's my ID for my less simple. But if I wanted to display at less simple, let's say I wanted to do, let's just call it my ID. Oop, that's going to be a self. And then let's just do print string self.id. Oh, I need to actually call that. So now if I do all simple dot, what I call it, my ID, we're going to see here, we're going to get an error because when it calls that underscore ID, less simple doesn't have it. So this is a construct that we have to make stuff private, is that we can make, we add a double underscore, and that's going to make something private, which means it's not going to be directly accessible by the child. And so if I actually were to take, let's see, so dump and display. So let's do that with display. Let's show you what happens there. So now, if I do that, here we go. Simple object has no attribute display because it is not, I have to actually call the private version of it. See, here, simple object has no attribute display. So even there, I cannot access it because it doesn't even see it. The only way I could do it would be in here. Then I can have a reference to it. And that allows you to do some sort of protected stuff. Now, I could do like in my ID, if I put it here. So now it has access to that private value. Oops. Did I do the... Oh, I didn't fix my display. Apologies. And so now it works because the ID is going to get it, but it's calling it up here. So within that class it can, but I cannot access those private properties within my child classes. And I think I'm going to hold off there. The next thing we're going to get into is there's actually multiple inheritance. And I guess before going, I do want to say that if you have you can do a module dot. So if you have a class within a module, sometimes we'll run it. We'll talk more about modules later, but I just wanted to touch on that in case you're looking at some examples and you see this kind of a syntax. Is that this means that the class is just available. If I want to do one within a specific module, then I'm going to have to, I'll give it a module name to define it. Sort of like, up here, if I wanted to do a specific type of random. And so we've walked through very basic inheritance and how things can, and then we can also extend, so I could add a whole new something here, well, which I did with the my ID. So I guess just to show how this works, let me do that. Let's do my address just in parting. So if I do address, and so that's for less simple. Now notice that means that I cannot call simple dot my address. It's going to blow up because less simple. Oh, sorry. Where did I do? I got to get rid of that one first. And so I see here, simple does not have my address. So it's a one-way relationship. This guy inherits from this. This does not inherit from there. And if I wanted to try this, just to show, if I want to try to make some circular reference, then what's going to happen is less simple has not been defined yet. So I cannot do a circular reference of inheritance. And that'll wrap it up for this time. I want to we're going to dig more into inheritance next time around, but I don't want to get too long on this one. So, as always, go out there, have yourself a great day, a great week, and we will talk to you next time.